Hello students, welcome back to the Tantray physics classes. Today I am discussing one more challenging problem with you, and this problem is on electrodynamics, where you see everything is involved. Maybe it is a capacitor, maybe inductor, maybe a resistor, maybe voltage source, everything regarding this electrodynamics is involved. Here we have a circuit which contains this battery, 18 volts. Resistance are to 6 kilo ohms, resistance R1 6 kilo ohms, and it is an inductor. It is an inductor L. The key is closed, already closed. The battery is inside this, connected to the circuit, and the key has been closed for quite some time. Means there's already a steady current through the inductor, constant current. Because when you connect a battery to an inductor through a resistor, it takes current to build up. It takes time for current to build up. But when the current is constant through the inductor, that's called a steady current, constant current. And when the current is constant after some time through the flux through the inductor does not change. When the flux through the inductor does not change, then there's no induced EMF, no potential difference across the inductor. And when there's no potential difference across the inductor can be considered as a short circuit. It is as good as a straight, ideal wire having no resistance. But by then, the current is constant. The moment current changes, there is induced EMF. Changing current will produce changing flux inside the inductor, and that will produce the potential difference, induced EMF. But here current is the current through the inductor is already constant value, so the inductor is a short, right? That we already have this. The key K is closed for a long time, therefore inductor is a short. Find the potential difference across the inductor, across the inductor when key is opened at t is equal to 0. When you open the key, I have to find what should be the potential difference across the inductor. That is my question. Potential difference across the inductor when the key is already closed is 0 because it is a short. And the moment this key is opened at t is equal to 0, at that very time at t is equal to 0, what is the potential difference across the inductor? That is my question. So how to solve this question? This circuit, I will convert this into another circuit, steady state circuit. That is something like this. Your resistance, 6 kilo ohm, and it is resistance again 6 kilo ohm. Now this is simply a short. Inductor is a short, is the inductor. It is a short, and this is battery here. This is a battery, 18 volts. The inductor has been there, the key has been closed there for a long time, and this inductor is a short. It is just an ideal wire. So how much the current flowing through this? And how much the current flowing through this? Current through this, it is 18. This potential difference between this point and this point is 18, and there is voltage across this resistor is 18. So this is how much is the voltage? Now how much is the current? 18 volts by 6 kilo ohm. That is 3 milliamperes. You can check it out. 18 divided by 6 is 3 milliamperes. How much is the current from here? That is again 3 milliamperes. Because again potential difference between this point and this point is 18, between this point and this point is again 18, and the current through this resistor is 3 milliamperes. So here current is 3 milliamperes through this, and through this current is again 3 milliamperes. And this same current flows through the inductor, which is here between these 2 points, right? But I have shown that inductor through a short circuit. Okay, now all of a sudden what I do, I open the key. I just open the key at t is equal to 0. So I want to know what happens at t is equal to 0. At t is equal to 0, key is opened. Key is opened. So what should happen? The moment key is opened, What is the circuit? The circuit is like this. When the key is opened, it is 6 kilo ohm, and it is 6 kilo ohm. It is inductor here. Here it is inductor, and like this. Because now when so it is opened, the battery goes. Okay, let me make it. The battery is like this. Battery is like this. Key is open. It is open. It's open circuit here. What was current from here? 3 milliamperes. At t is equal to 0, the current was flowing through this 3 milliamperes. The current was flowing 3 milliamperes. The moment you open the key, the current here is 3 milliamperes. But immediately when you open the key, this potential difference will not send any current through this 6 kilo ohm resistance, because this voltage was sending current through this 6 kilo ohm resistor. This 18 volt battery was sending current 3 milliamperes through the inductor. But when you switch it off, when you open the key, the current from here, it will not send any current through here, but current through here will remain the same, because this inductor will sustain that current. ऐसा मत सोचो कि जैसे आपने इसको ओपन किया और ये करंट जो है 3 एम्पियर करंट 0 हो गया, ये करंट खत्म हो गया, लेकिन ये करंट खत्म नहीं होगा. इस करंट को ये इंडक्टर सस्टेन करेगा, क्योंकि दिस इंडक्टर विल नॉट अलाउ द करंट टू डाई इमीडिएटली एट t is equal to 0. It will try to sustain the current. It will try to keep the current constant at t is equal to 0. So at t is equal to 0, when the key is opened, the current through the inductor is 3 milliamperes. It will not die down, because the moment current tends to die down, there is a change in flux, and that change in flux will try to keep the current constant. So at t is equal to 0, the current through the inductor is 3 milliamperes, and this current will find its way. It will not pass through what? Through the battery. Instead, it will pass through this 6 ohm resistor and will complete the circuit like this. At t is equal to 0. After some time, the current will decay. Finally, the current will become 0. But at t is equal to 0, the inductor will try to sustain the current. It will try to keep the current constant. That is the point. So at t is equal to 0, when you open the key, the current this battery was sending through this resistor will become 0. But the current through this will not become 0, because this inductor will sustain that current. It will keep that current constant, but that current will find its path through this resistor, not through the battery, because battery is already cut. Okay, now what should be the potential difference between A and B? What should be the potential difference between A and B? So current is like this. It is okay. It is positive, negative, because current flows from higher potential to lower potential, and here it is positive to negative, because from higher to lower potential. So what is potential difference between B and A? So okay, either you do VA and VB or VB and VA. So VB minus VA, potential difference across this inductor. So जाइए यहाँ से sum the voltage up to here, from here to here. So potential here VB minus VA is, यहाँ से जाइए, यहाँ से potential drop. Potential drop is 6 kilo ohm into 3 milliamperes, because 3 milliamperes is the current flowing. 3 milliamperes plus voltage drop plus potential difference between the 2 points is sum of the voltage drops. From when you go from B to A, sum the drops. Drops को जो भी drop आएगा आगे उसको sum कर दो. ये है एक drop, ये दूसरा drop, that is 6 kilo ohm into 3 milliamperes. This is 18 volt, because milli and kilo cancels off, in 18 volt plus 18 volt, that is 36 volts. अच्छा खासा potential difference develop होता है across the inductor at t is equal to 0, right? But after some time, this voltage will decay, because current will also decay, but it is only after some time. At t is equal to 0, there will be a good voltage, appreciable voltage between point A and point B, and it needs to be noted down that potential difference across the inductor is more than the voltage of the battery, which we have disconnected. So this was one more challenging problem for you, and continue to watch this series. I am continuously giving lectures on challenging problems. But some problems may be easy, some may be difficult, some may be more difficult. It's a spectrum of problems that I am going to discuss on the YouTube. Thank you.